angles, how do I find the lengths of chords, secants, and tangents now? How do I find those lengths? All right. So I'm going to start with this proof right here. And this proof is not a new proof. It is something we have reviewed in the past. So I'm not really going to say a word about it. How do I prove AE times BE equals CE times DE? First thing I'm going to ask, what unit did this come from? So we know kind of where we are right now. What unit did I ask you to prove something like this in? We'll sooner or later get to it. Same thing happened period 2, but eventually we got it. When I proved these two segments multiplied equal these two segments multiplied. Got it, Charlotte? Keep going. Means and extremes. Yep, product of the means equals product of the extremes. Good. Before I did that, though, something needed to be true about my diagram. This will tell you what unit we were in, Paul. Similar triangles. This is similar triangle unit, correct. So we are going to prove these two triangles similar. What's the main method? There are 3 methods, but when we do a proof, we only use one of them. And that method is angle, angle. All right, so our goal right now I'm going to start calling on numbers. Find me 2 pairs of angles that are congruent in this circle. All of which you know are congruent based on different theorems. So give me 1 pair of congruent angles up here right now. There it is. Oh, 23. Yep. Didn't need to know anything about circles for that one. CEB is congruent to angle AED. Vertical angles are congruent. One angle down, one more to go. You know which pairs it has to be. I wouldn't ask you to prove them similar if they weren't congruent. Now you just got to figure out why they're congruent. You know it's going to be C and A, or it's B and D. You just got to tell me why. So I'm just going to write one of them down right now. C congruent to A. I could also write B congruent to D. It's going to be the same reason. I don't care which one you write down. Same reason why they're congruent. This is a former theorem done in this unit. Why are C and A congruent to each other? Let's go 5.
Describe angles drawn to the same arc in a circle.
R. There you go. Good, Greg. Inscribed angles, which they are. Drawn to the same arc, which they are. Are congruent. We're good to go. Now you can say the triangles are similar. Triangle CEB, similar to AED. Just watch yourself. Make sure you're putting the similar sign, not the congruent sign. Watch yourself. Charlotte mentioned product of the means equals product of the extremes, which will be our final reason, but there's an in-between step. We cannot say the triangles are similar, therefore the means and extremes are equal. I need means and extremes first. So anybody remember that in-between step? Sriya?
Say AE over CE is equal to BE over DE.
I need by proportion. I need means and extremes written down. And means and extremes come from a proportion. So AE, it's got to go somewhere. But remember, I need to multiply that with BE. So it can't go underneath, can't go to the right. It's got to go diagonal. Because that's how I solve proportions, cross multiply. So AE, BE's got to go here. They're your extremes. And then CE and DE. Why? Not means and extremes are our last reason for the proof statement. Ooh. Triangles are similar, so why did I put those sides in a proportion? Anybody remember the reason here? The triangles were similar, so I just put the sides in proportion. Corresponding sides in proportion.
CSST.
Corresponding sides, similar triangles are proportional. It's the similar version of CPCTC. All right, now you can multiply in means and extremes, and we're good. AE times BE equals CE times DE. Product of the means equals product of the extremes. All right, little good review. And that's the what we're going to be talking about today. What did we just figure out about a circle? What are CD and AB in my diagram? What are CD and AB? Those are what in the circle? One, Meg, what are CD and AB, please? Chords, and they're both intersecting. Everyone agree? Two chords. When two chords intersect, so when two chords intersect, look at what we just did. AE times BE equals CE times ED. When two chords intersect, let's write that out a little more official. When you multiply two numbers, what's the answer called again? Product, thank you. So when two chords intersect, the product of their segments are equal. Don't write this on your diagram, please. Do not write this. I just want to show you exactly what I mean. That's probably not good. 2 and 8. See what I mean? 8 times 2, the same as 4 times 4. That'll always happen in a circle when the chords intersect. The product of their segments are always going to be equal. All good? Questions? All right, let's apply it like usual. I'll give you a basic one, then we're just going to go right to honors real quick. So everyone see the two chords in problem 1? Two chords intersecting. So now the product of their segments are equal. So set up an equation for me that says these two multiplied together are the same value as these two multiplied together. 20?
2 times x
Yep.
equals 8 times 2.5.
2 times x equals 8 times 2.5. There's that theorem in action now. In action. Two chords intersect. Yep, let's get the calcs out. Get 20 here. X is 10 for that one. Is a diameter a chord? Is a diameter a chord? Yeah, so this new fact still would apply to a diameter and just a regular chord intersecting each other, which I have in number 2. Here's an honors level problem for number 2. Do you see two chords intersecting? Do we see two chords? Let me highlight them. Don't do it yourself, which is going to make a mess. Here is chord number 1, the diameter, and here is chord number 2. Everyone see the two chords intersecting? So their segments, when I multiply them, are equal to each other. So let's start with my green chord right now. My green chord. What are the segments on the green chord I've created? 16? 8 and 10. So 8 times 10 will be the same value of, now let's go to my yellow chord, aka the diameter. One segment's already labeled for you. What is it? One segment already labeled. 24? What's one segment that's already labeled on that yellow chord? Remember, I cut it up into two segments. Like I have 8 and 10. For the yellow chord up here, my diameter, I have what? X. That's the one I'm given. Now, this is why it's an honors level problem. How do I represent the other part of the chord? Everyone see what part I'm talking about? I hate going all these multicolors, but I'll put this in brown. From here to here is the other segment. X is 1. What's the other segment I just highlighted in brown now? And I probably gave you that 12 for a reason, right? What's up, Lauren?
12 plus 12 minus x.
Okay, combine them.
24 minus x.
Okay. 12 is a radius, meaning what's my diameter? 24, which is my old yellow segment there. I already know one part's x. If the whole thing was 24, Lauren again. 24 minus x. Everyone see how that worked? Segment times segment, 8 and 10. X times the other part, which is 24 minus x. Now, we're not going to like how we're going to solve this, but hey, that's why we signed up for honors. Minus x squared. What's your next move? After I distribute the x. Yep, Tammy?
I mean, you can add x squared to the other side, I guess, to make it positive.
Okay. But I still got the 24x there.
Oh, and then I guess you can. X.
You're basically telling me get one side equal to what?
0.
Get one side equal to 0 because you know this is going to be a factoring problem. And yes, it's convenient for me to move the 80 over. Not liking this though, negative x squared. Not a big fan of that at all. So yeah, it might be more convenient for you and easier, less I'm not going to say lazy. Move over the 80, but I'm moving this side over. All right? I don't want a negative x squared in the house. So I'm going to make it positive, move it over. The negative 24x now, and the 80 remains positive. All right. What are you looking for? Two numbers that do what now? It's factor time. Two numbers that do what? I'm not going to give them to you, but multiply to 80, but at the same time, we'll add to negative 24. Find them. Find them. I know 10 and 8 are the first ones that come to mind when you say multiply to 80, but that's not going to be 24. Oh, how about 2 and 40? No, that's silly. How about 1 and 80? He's just being a jerk now. You are correct. I think 16 and 5 multiply to 80. Well, still not going to work.
So sorry to
What's
bother
up?
you there. I have to change your supervision. Don't shoot the messenger. See, I can say in front of a class where he can't get angry at me.
What days are we talking here?
Just one.
What day?
Period 5, Monday.
Oh, that's fine.
Is that
as long as
okay?
it wasn't the Friday.
No.
'Cause that double period is
Okay, no.
that's sacred.
Then we're
here.
good.
That's sacred.
Okay.
Yeah. What are we doing?
Hall duty.
Instead of what, study hall?
Yes, study hall. You sure? You want.
As long as it's on Friday, that's all it's about. What were the numbers? Actually, why am I waiting? Everyone should have them, right? 22? Ooh, lucky. 5?
Negative 4, negative 20.
Good job. Negative 4, negative 20. All right, still not out of the woods yet. There's a reason why I called this an honor level problem. not just for the 24 minus x or the factoring, also for this part here. I'm going to get x equals 20 as an answer and x equals 4. Are both okay? Because usually when we factor, we got to just keep in the back of our mind, I may be rejecting an answer here. And usually we see a negative number and we reject that, but I don't see one here. But I still want to reject one. Why? One of them just doesn't make sense. Jonah, which one doesn't make sense?
The 20, because then it would be like that chord would have to be past the mid or the.
Yeah. Well, what's the radius?
The radius is 12.
So you're telling me this segment that's part of a radius is bigger than it? I don't think so, right? Everyone, that makes sense? I can't have that little segment be bigger than the radius if it's part of it. So see you later to 20. Where am I here? There's my x. See you later to 20. I got 4. All good? All right, next up. Okay, we're finding the entire length of CD right now. It's 3 centimeters from the center. Can you guys put a 3 centimeters from the center? Chord CD, 3 centimeters from the center. Radius is 5. Can I plug the 5 anywhere? Radius is 5? Or can I put a 5 on this diagram? Center to what point? B. I could do it there. And can I fill out from A to the intersection point too? How long is that? From A to the intersection point? 8? 2. Yeah, the radius was 5. I know a little bit of it's 3, so this rest's got to be 2. Do you see 2 chords intersecting? Yes? Do we see 2 chords or do I have to highlight them? Let's talk about chord AB. Give me the 2 segments that are made up of chord AB. This times this. Chord AB is made up of this segment length and this segment length. Chord AB is broken up into, name the segments. 14, yeah. 21. Great job. 2. And then from the intersection to B, 8. Awesome. Now let's go to the other chord, CD. I don't have any labels for those. Anybody see a theorem going on here? Charlotte, theorem?
The diameter is perpendicular to the chord, so it bisects it.
Chord's getting bisected here because it's perpendicular to the diameter. Nice! So now what can I just plop in here now? And they're both the same. I'll find 1 and double it to find the CD. X squared equals 16. X equals 4. Not the finish. Not the finish. X is 4. So CD will be. How long is that chord now? 17. How long is that bad boy?
8.
8. Yep, centimeters. All good? You're on your own for the last one there before we go to the new theorem. All right, you're on your own there. You got numbers in a ratio, which doesn't scare me and shouldn't scare you. All right, let's see what we got here. Make sure we set it up correctly first. I knew that was going to happen.
3x and 4x.
3x, 4x. We're good. Next thing, I got 2 chords intersecting, so the product of their segments are equal. Represent that for me now. 4. Griff, give me 2 segments you know.
16 times 3 is equal to 3x and 4x.
Good. None of this problem worried me except for right here, what you guys did with that, with your fine algebra skills. 48, 12x squared, not 7x, not 12x, 12x squared. Get the 12 out of there. x squared equals 4, x equals 2. Make sure we go back and solve the problem now, though. 2 leads me to my answer. So what about RE and ES? 10, RE,
6.
6, ES, 8. And if you do a quick check, 16 times 3, 48. 6 times 8, 48. So it comes out perfectly. All right, one last little theorem amongst the many in this unit, right? Amongst the many. If, speaking of chords, if they're parallel to each other, if I take 2 chords and make them parallel, the arcs in between are now congruent. All right, so if you are given that 2 chords are parallel, the arcs in between them are congruent. Okay, the arcs in between them are congruent. They got to be parallel, though. They just can't be 2 chords randomly drawn in. They got to be parallel. The arcs in between are now congruent. All right, I'll do the first problem. You got the other 2. So here's this theorem right away. AB parallel to CD. Oh, that must mean arc AC is congruent to arc DB. Their measures are the same. Arc AB is 80. How about arc CA? How about arc CA there? How can I get to arc CA? I know it's equal to DB at least, but how do I get there? How do I get there? I got the 80 there for you. 11, a little help.
50.
Where are you going with it? Yeah, it's right, but how?
It's a semicircle.
Okay, thank you. Don't forget the darn diameter that's there. Semicircle, how many degrees, Paul?
180.
180. I already have 80. And then divide it all by 2. And that's where we come up with the 50 degrees. All right. You got the other 2. I'll write the answers up here, but you got the other 2 on your own now before we get to the homework. You got 140 or 125? Keep trucking. Keep trucking. If not, call me over. And also a heads up, the answer key. The answer key tonight starts with question number 2. I didn't put the answer to question 1 because I figured we just would have no problem with that. So the answer key starts with question number 2, FYI.